yesterday we learned about the different types of variation. Okay, so it's important that you can recognize where in the problem they're going to tell you how these variables are related. So the time t needed to complete a certain race varies inversely as the runner's average speed s. Okay, so the time t varies inversely as the average speed s. Okay, so Cody, if we're writing an equation from that, what would that be? Great. T equals k over s. Okay, and then your first step, once you have your equation, we are going to have to use the given information to find k. Alright, so I want you to either highlight or underline the given information you're going to use to find the value of k. Oh, yeah. What did I do wrong?
No. I charged it when I forgot.
Oh,
Yeah. No.
Ow. Okay, so when you're finding k, you are going to use your calculator for this one. Okay, so a runner with an average speed of 8.82 miles an hour completes a race in 2.97 hours. Okay, so we're going to plug in our variables. Okay, and some of you might find it helpful to just identify what each one is. So this is the speed, 8.82 miles an hour. Okay, and then for the 2.97 hours, okay, this hours, that's going to be a unit of time. Alright, so we're going to substitute those in. So I have 2.97 equals k over s. Alright, so Royal, if I'm solving that for k, what am I going to do to both sides? Yep, so our s value is 8.82. So you guys can multiply that out. Okay, and then Keenan, let me know what you get for k to the nearest. We give me 3 decimal places after.
26.196.
Okay, and then I'm gonna put this out like that. Okay, so we're gonna round to the nearest hundredth, and I wanted us to do this together. So when you are rounding, okay, to the nearest hundredth, you look at this third place. If it's a rounding situation, you have to put 26.20. Don't leave off the 0, okay, if it's to the nearest hundredth. And of course, if you have an assessment, it'll tell you what to round to, okay, for your homework problems, you can just round to the nearest hundredth. Now, in the directions, it says, write the variation equation for the time t it takes for a runner to complete the race with an average speed of s. This is something that we practiced yesterday. Okay, so the variation equation is just t equals 26.20 over s. Alright, and then we can solve the last bit. So what is the average speed of a runner who completes the race in 3.5 hours? So when they're saying what is the average speed, what they're telling you to do is find s when the time is 3.5 hours. That is very similar to the setup that we did yesterday. Okay, so we can plug in the T is 3.5. Okay, so Nolan, if we're going to solve this for S, what would you do first?
I would divide by 26.
You would divide that first? You divide this on both sides? So what would that be equal to? I mean, technically you can divide it, but you know what that would be equal to? 3.5 over 26.20?
21.335.
And do you know what would be on the other side of the equation if you did that?
1 over 10.
Yeah, it would be 1 over the S. So if the S is in the denominator, you can multiply by S. Or I wasn't sure, would some of you set up a proportion and cross multiply? Okay, yeah, so you can put this value under 1 and you can cross multiply here. And then once you multiply by S, can you guys see that you're going to divide by S on this side?
Yeah.
Or divide by S, divide by the 3.5. Okay, so you have 3.5 S. S's are difficult because they look like 5 sometimes. I feel like on the last quiz, some people couldn't read their own handwriting. I can't remember if it was your guys' quiz or quiz. Now, whenever you have your story problems, okay, you are gonna have to include your units. Right? And again, just be careful, like I said, with the variable S. Nobody's going to say that one for a 5. Okay, so then you get 7.49 miles per hour. Okay, and then from there, we are going to do example 9. For example 9, I must have put the wrong paper in the copier, so yours has the last 2 sentences matched together. Okay, so I'm going to show you what it should say, and then we're going to kind of troubleshoot that together. Okay, so a question about this one?
Yeah, I didn't round originally with K, and I thought that's how we were supposed to do it to like get the more accurate.
Just round to the nearest 100 on your homework. Oh, you're saying
For K.
oh, when you did that, yeah, that's fine. And then so you got 7.48.
Yeah.
Yeah, yep, that's okay. And then when you are notating that, just put the dot. You know, you want to check it right here, and that just means you're using the full value and not the value. Okay, so example 9. Now, some of you may have done problems like this in chemistry. Use them on the knowledge. Okay, so the change in temperature T of an aluminum wire varies inversely as its mass M and directly as the amount of heat energy E that is transferred. Okay, that first line is going to tell you what your equation should be. So we always start with what we're given. So it's the change in the temperature T. If it varies inversely, M goes in the denominator. If it's directly, E goes in the numerator. And then what one other variable do I need? K. You always need your K. So the K is always going to be on top there. Okay, so what yours should say is that a temperature of an aluminum wire with a mass of 0.1 kilograms, okay, rises 5 degrees Celsius when 450 joules of heat energy is transferred to it. Okay, so we're just going to add that little part in there. Okay, so let's see how yours has those combined. So we're just gonna say when the heat energy is transferred to it. And then there should be a new sentence that says, we'll just say how much heat. Okay, how much heat must be transferred to an aluminum wire with a mass of 0.2 kilograms to raise its temperature to 20 degrees Celsius. Okay, because without that breakage, does not make sense. Okay, so the heat energy is transferred to it, and then your next sentence, how much heat must be transferred, is what you should have. Okay. Alright, so when they give you this trio, that's what you're going to use in order to solve. Okay, we're going to do this without a calculator. Don't be scared. Okay, we are going to find K. So our first objective is always to find K. So one thing I find helpful is just writing what you should go in for. So the 0.1 kilograms, that is your mass. Okay, the 5 degrees Celsius is going to go in for what? What's one of our variables? T, temperature.
Oh.
Okay, and then the 450 is going to be your joules. So you guys work with joules in your science class? Okay.
Very bad.
This, oh, you mean, I was like, this isn't going to be bad. Okay, so 5 is equal to K times, and then you have 450 divided by 0.1. Alright, so if you have to divide it by 0.1, you can multiply by 0.1 first. That's what I would recommend. Because 0.1 times 5 is just what? 0.5. Okay, so then I have 450 times K. Now to get K alone, we want to divide, but we don't want to have a decimal within a fraction. And remember, I said we're going to do this without our calculator. So if you don't have your calculator, okay, what would be a way I could simplify this so I don't have that decimal in there? Do what? You could do times 10 over 10, right? Oh, you could also do times 2 over 2, right? So if your decimal is not a half, I would do 10 over 10. But because this is a half, I would multiply by 2 over 2. Because if you double it, right? What's 2 times 0.5? 1. What's 2 times 450? 900. Okay, so that's your value of K. So this is going to be your exact value. Okay, an exact value is not rounded. Alright, so I'm going to let you leave it as 1 over 900 in your variation equation, but we are going to talk about a way to simplify it, especially because you have the SAT coming up and there are different ways you can simplify. Okay, so your variation equation would be T equals 1 over 900E divided by the mass M.
So when you're like, I know that makes sense, but when you're like simplify the equation like the form of the form, like starting side.
Yeah, you could divide that, and then you could, after you divide that, divide each side by this, and again, you end up with the 1 over 900. Yeah, yep. And then for step 2, we didn't do step 2 two first, and then I'm gonna come back and show you how to simplify this. Okay, so for step 2, how much heat must be transferred to an aluminum wire with a mass of 0.2 kilograms to raise the temperature to 20 degrees Celsius. Okay, so they tell you the mass is 0.2 kilograms. Okay, they tell you the temperature is 20 degrees Celsius. And then we have to find how much heat must be transferred. Okay, so that means we're going to find E. Alright, so then our T is going to equal 1 over 900 times E. So, and then, yeah, you can put in your 20 here. Over 0.2. And that's plug in the 20 right away. Okay, and then from here, you can multiply both sides by 0.2. You always want to multiply by the denominator, right? Because if you multiply by the denominator, these are going to cancel. Okay, and if you're not comfortable multiplying with decimals, every decimal you can rewrite as a fraction. If it's 0.2, that's going to be what? So you can write it as 1/5 of first. You guys probably just know 0.2 is a fifth. Okay, if you don't know that 0.2 is a fifth, you do know it's in what place? The tens place. So you can do 2 tenths, which is, sorry guys, you're doing 4/5 at first. Okay, so 1/5 times 20 is going to be what? 4. This one will just be 4. Okay, and then if you have 1 over 900 E, you're just going to multiply both sides by. Okay, so then once you multiply, okay, you're going to cancel here. And then 9 times 4 is 36. And then you just again have to put your units on this. Okay, so it's going to be 3,600 joules. Okay, so, like I said, sometimes you might have simpler versions of this equation. Another way that you can think of this is you can multiply 1/900 by E. How would you write that as one term? E over 900. Okay, so you could do E over 900 divided by M. And if you do the keep change flip, you would keep E over 900. You would flip the M. And if you flip that, what is the fraction? 1 over M. Okay, so this would be E over 900 M. That would be another way you could write this equation. P equals E over 900 M. Okay, so sometimes when you're taking multiple choice tests, you might not see this as one of the answers, but you might see this as an equivalent answer. Because it looks simpler, right? Technically, you shouldn't have a fraction in a fraction, but for this, it's okay. Alright, so your task for today is to finish 9.5 if you have it. I can see some of you already did.